So first let's take a look at divergent boundaries. You guys already told me what's happening when you diverge. You're moving apart. Okay, so it's when our two plates are being pulled apart. Okay, the Mid-Atlantic Ridge is a perfect example of a divergent plate boundary. You might want to note that. So the Mid-Atlantic Ridge is an example of a divergent plate boundary between the North American plate and the African plate. For the most part, you're going to find divergent plate boundaries in the ocean. We don't really find that much on land, but there are a few locations where we have seen them on land. We'll talk about that here in a minute. So let's take a look at our little diagram here. So look at divergent boundaries. And basically what happens is you have this upwelling of magma coming up from the seafloor, and it literally spreads the ocean floor apart. So think of it as literally wedging itself up, and then as it cools, it pushes away. So this is like the driving mechanism behind seafloor spreading. This is that ridge push. Whereas the new material is being cooled, it becomes more dense and actually pushes the other material toward the trench. And so we get these ridges that start to create along the boundary. So, I want you guys to tell me, where's the places we have plate bound or divergent plate boundaries? I've already put you guys in the Mid-Atlantic Ridge. Where are some others that you can think of? Where are there two plates that are moving apart besides the Atlantic Ocean? Really? Just have no clue?
This is an all-call for any students who still need picture retakes or need to have your picture taken. Please report to room 218.
Nothing? Where else do we find divergent plate boundaries? So it's not just the Atlantic Ocean. There's other places around the world where we are separated. Well, where? Where in the mountains? Which mountains? Yeah, well then let's take a look at it. Down through here, this is what we call the East African Rift. Remember we said that for the most part divergent plate boundaries occur underwater, right, and they're on the sea floor. When they occur on land, we call that a rift valley. So a rift valley. So when they occur on land, we basically create this rift valley. And in fact, there's a rift in Africa. And it basically creates a chain of lakes down the whole stretch of the East African continent. And these lakes are very, very long, they're thin, but they're super deep. And that's because of the rift valley that's created. Other places you can find, remember we talked about the Mississippi River? This is an old divergent plate boundary. Very, very old. It dates back prior to Pangea. This is a very, very old rift. And basically what happens is the land of the underneath the river actually sinks down. And that's why the river basically takes over that basin. Remember, because the river is going to go to the lowest point. In fact, right here, I know you guys can't really see it, let's see if we can zoom in. There's a little town in Missouri. Called New Madrid, not New Madrid. Locals they actually don't know how to pronounce anything. So it's called New Madrid. And there's a fault line that actually goes through New Madrid that during the last earthquake on the New Madrid fault line was so severe it actually forced the Mississippi River to flow north instead of south. So this is a very, very strong fault line, but it's very old, so it doesn't really get a lot of earthquakes that often. Another one, now a lot of us should be concerned with, are the Great Lakes. So remember we talked about the East African Rift and how you had these chain of lakes that form anytime you have a divergent plate boundary? We just talked about that. So what we look at with the Great Lakes, we have the same situation. Where you have a divergent boundary through the Great Lakes, all the way out to the St. Lawrence Seaway. So the St. Lawrence Seaway is actually there for a reason. It's an old divergent boundary on the North American plate. And that's actually how our Great Lakes are formed. And this is where sometimes I think we get confused when we say, well, how did the Great Lakes form? Well, glaciers carved them. No, they didn't. All the glacier did was fill the hole that was already there. That's all the glacier did. And so when you think about our glaciers coming in, these are fingers of a big ice sheet. Well, what the fingers actually did is they simply filled the gap with ice that eventually melted and filled it with water. They didn't actually carve out the Great Lakes. Okay, this is pretty flat terrain. You shouldn't expect that the glaciers are going to carve out these holes. So again, when we look at these, they're actually divergent plate boundaries. What's more important and kind of unique, if you guys ever want to take a summer trip and you're interested in earth science, the place to go is the UP, Upper Peninsula of Michigan. This little guy right here is called the Keweenaw. Keweenaw Peninsula. What's cool about the Keweenaw is it's actually basically the Keweenaw is a volcanic ridge. The whole length of it is ancient volcanoes. In fact, you can actually see, if you know where to look in the Keweenaw, you can see pillow lava still in the landscape. And it's kind of a really neat thing. In fact, there's a little tourist little town called Copper Harbor, right here at the tip. And you used to be able to take tours of the old copper mine. So you get a lot of volcanism occurring on this plate boundary, and that's because you get a lot of heat and pressure being released. So that's when we find a lot of our natural minerals. I'm not sure, again, if you guys know much about your Midwest history, but this Upper Peninsula, as you can kind of see, used to be part of Wisconsin. See how that kind of makes sense when they're starting to buy out the states? Well, there was this ancient battle. I shouldn't say ancient. It was during the early ages of the states. There's this battle between Michigan and Ohio, because at one time Michigan had Toledo as part of Michigan's territory. And basically, this is where we started getting the whole Buckeye versus Michigan Wolverines. This is where that ancient rivalry is coming through. And it's basically out of this battle over Toledo, which Ohio won. And it was basically decided in the Supreme Court. And what was decided is, fine, we're going to give Toledo to Ohio. Well, what's funny is Michigan threw a big fit about that. Because at that time, Toledo was a major hub of shipping. So there was a lot of money coming into Toledo. But it was actually Michigan who made it, was actually richer in the long run, because the Supreme Court then cut off the UP and gave that to Michigan. And when you think about all the natural resources, all the iron and the copper and the silver that comes out of the Upper Peninsula, not to mention the logging that fueled the boom, the economy booms of the 1800s, that was all part of Michigan's natural resources. So it was actually, Michigan definitely won that deal, lost Toledo, but gained on the natural resources.